Right, a water tank is filled to a height of 4 meters. A tap at the bottom of the tank is opened and lets out water in such a way that the level of the water H above the bottom of the tank decreases at a rate equal to 0.01 root H. Write down the differential equation satisfied by H and solve it to find out how long it takes for the tank to completely empty. Okay, so in this case, right, we're looking at the water H meters above the bottom of the tank, and it decreases at a rate. So we're looking at, to set up our differential equation, our differential is going to be dH by dt, isn't it? Because we're looking at how H changes with respect to time. And of course, its height is decreasing, isn't it? So if it was a curve, you'd see it sloping downwards. So the gradient, how H changes with time, will be negative. What I want you to notice in this question as well, which is different to the previous ones, notice it says is equal to. Okay, it doesn't say proportional, it literally says equal to. So we can put equals there to what it is, minus, of course, of this. It's important, as I said, it's important you put that minus there because it's decreasing. We have to have negative differential here. We have to have a negative gradient because the height is decreasing, sloping down. So minus 0.01 root H. So there is my differential equation straight away. Okay. So we're then going to separate the variables. Okay. If we separate the variables, we get the h's on one side and the t's on the other side. Okay. So in this case, you've got the root h on the top here, times in by minus 0.01. Leave the minus 0.01 where it is, and because this is on top, take it over and divide. So you've got 1 there, divide by root h with respect to h, and then you've got minus 0.01 dt. Okay, so there is your separated the variables there. Okay, and we can integrate this. And of course, before we integrate, we need to take that up. Remember, root h, square root of h is h to the power half. Okay, so when you take it up, it'll be h to the power minus half with respect to h. And then we can integrate. So to integrate that, h to the power minus half, will add 1 onto it. So if I add 1 onto minus half, it becomes a half. And then divide by that new power half, equals to minus 0.01, then is a constant integrated, so it becomes minus 0.01t, plus then a constant. Okay, now I can tidy this up a little bit, because I've got half on the bottom. I can take that 2 up there, flip it so I get 2 on top. H to the power half is square root of h, yeah, that's what h to the power half means. Minus 0.01 t plus c. Okay, so it says write down differential equation satisfied by h, but we did that there, and solve it to find how long it takes for the tank to completely empty. So we haven't quite solved it yet because we've still got this constant here. We need to work out the constant. To work out the constant, we need some sort of initial condition, no? Or we need a condition at some point throughout it. Can you see anywhere here where we've got values given to us? And in fact, the first line is there. Tank is filled to a height of 4 meters, and then it's opened. Yeah, the tap is open. So it's 4 meters before the tap is opened. Yeah. So we can say, look, at the start, when t is 0, h is equal to 4. Right. So we'll have 2 square root of 4 equals to minus 0.01 times 0 plus c. Okay, so that means then, well, that will be 0, won't it? Okay, so c is equal to that, and 2 root 4 is just equal to 4 when you work that out. Okay, so therefore 2 root h is equal to minus 0.01 t plus 4. There's your constant. So we need to get h equals. So let's take that 2 over. Okay. So we'll have root h equals, now if I take the 2 over, I've got to divide by 2 essentially, yeah? Throw it by 2. So then, if I do that, I will get minus 0.005t plus then 4 divided by 2 is 2. Okay? And of course, to get h equals, well, I got to take the square root over and of course to the opposite. The opposite of square rooting is squaring. Okay, so it'll be bracket this. Let's write them the other way around maybe. So 2 minus 0.05005t squared. So there's my solved differential equation there, right? I've solved it. And then it says find how long it takes for the tank to completely empty. Well, of course, when it's empty, h will be 0, won't it? Yeah? H will be 0. So we can say that when it is empty, h is 0. That means 0 here. So all of this is equal to 0. And if this squared is equal to 0, that means then that the thing inside the bracket is equal to 0. I keep missing out the 0 there, don't I? Okay, so rearrange it and you can get t equals. So t will equal then 2 divided by 0.005. Okay, so if I do that on my calculator, I will get 400 seconds.